Hi class. So this video we are looking at hypotheses, and in statistics, statisticians, I mean, they always got to go the extra mile. They don't just make one hypothesis. Whenever they're doing a test, they always have two. Okay, and the first one is called the null hypothesis, and the symbol for that is an H with a little zero. It's like H naught. And typically when we're doing hypotheses, we're testing, we're making conjectures about population averages or population means. So anyways, the first one is the null hypothesis. The second one is the alternative hypothesis. Okay. And for that one, the symbol for that is an H1. And again, we're saying something about the mean. Okay. So here's how this works. We have some population that we're studying. We want to know something. Let's say we want to know how many, an apple a day keeps the doctor away. Or is that the saying? So how many apples? Do people eat in a month? Okay. And so we have this, there's approximately 30 days in a month. And so let's say that we believe, nobody's perfect, right? So they probably miss a day or two. So let's say that we believe that people are actually eating, let's say that people are health nuts. So we think that they're actually eating more than 30 apples a month. So what we want to do, the thing that we believe, class, the thing that we're trying to prove, this is what we believe, right? We believe this. Okay? That's the thing we're trying to prove. So we believe that the average of the population is actually greater than 30. Okay? That's what we believe. And so what we're going to do then, for some reason, is we're going to spend the rest of the study trying to reject the null hypothesis. And so the null hypothesis is going to be that the average is actually 30. Okay? So the way we set this up is we have the null hypothesis that it equals some value, and then we come down here to the alternative and we say, okay, well, what do we believe, right? We could believe that it's greater than, we could believe that it's less than, or we could also believe that it's not equal to. Okay, so these are like we believe statements, right? If we're saying, and depending on like what we say and how we say it, that determines the type of test we're going to do. So for example, if we say that we believe, which we are saying, that we believe that people are health nuts, so they're eating more than 30 apples in a given month. Then the type of test we're going to do is, okay, again, looking at our distribution, is we're going to do a right-tailed test. Right? Because we think that, right, here's where the average would be. And we think that the average is greater. Okay? And so the cool thing about this, by the way, is that the inequality sign points in the direction of the test. So you do this kind of an arrow that's like pointing to the right. But that's why we have a one-tailed right-sided test. Okay? If we were saying that we believed that it was less than 30, then again, that is the worst normal distribution I've ever drawn. Oh my goodness, that's just as bad. I can't draw that. Okay, that's okay. All right, here's the mean. Again, look at this one's pointing to the left. So we're doing a one-sided test where we're testing values to the left. And if we say that we don't think that it's 30, then that looks like this. That's a two-tailed test where we split up our test stuff to both sides. Okay, so if you have questions that asks about so these are both one-tailed test. And again, those match the inequalities, right? And the side of the test you can tell because the inequality points to the side that you're testing, which is really nice. And then this is our only option for the two-tailed test. Okay, and it's the one where we say that it's not equal to. And every one of these stands in opposition to the null, which we're saying does equal some value. And so, and then what we're trying to do is we're trying to disprove the null. Okay, we're trying to reject. We want to reject the null, and we want to accept the alternative hypothesis. But that's kind of further down the road as we get into our study a little bit more. But looking at this, right? Now that I've colored all over this, you have the null hypothesis. That's when you're trying to reject. That's the one that uses just the equal sign. You have the alternative hypothesis. This is the one that you actually believe. And so you just need to look at your, and you have 3 different options for this one, and you just need to look at your study to kind of see what you believe. In this case, we're saying that we believe that people are actually eating more than, which is why we use the greater than sign. We believe that they're actually eating more than 30 apples a day. So that looks like this, which leads me to this type of test, a one-tailed right-sided test. Okay. And so that's a little bit about the 2 hypotheses, right? Statisticians always have 2 when they're testing a sample. They have the null and they have the alternative. And you can kind of see and hear the way that these 2 tests work with each other. And now the last thing that we can look at is, oops, let's go this way, is the types of errors we can commit. Okay. So 2 types of errors we can commit. So there's type 1 and type 2. Okay, so to boil this down, the type 1 error, this is when we reject the null. We reject the null hypothesis when it's true, when it's actually true. Okay, and this one is and again, look at this language, we fail to reject the null when it's false. Okay, so in a type 1, we're actually rejecting the null, which means we're accepting our alternative, but when the null was actually the true one. So that's why it's an error. And this one, we fail to reject the null when it was actually false, right? So 2 types of errors we can commit when we're doing these types of studies. And so when you're looking at questions that are trying to make you see, like, well, what type of error are you committing? You want to look and see what you're doing. Look and see, okay, well, what did I do? Did I accept or reject the null? Or, excuse me, I shouldn't say accept. Did I fail to reject the null? And was it actually false? Or did I reject the null when it was actually true? Okay, so those are the 2 things that you need to think about when you're trying to decide which type of error you're committing. Now, if you want to know, now we have a little bit of control over the probability of committing one type of error over the other, okay? And when you're doing a study, you always set this thing called the alpha level. And so the alpha level is related to the critical value. And with our alpha level, normally you're stating, essentially you're stating the amount of risk that it's sometimes called the significance value. Significance value, it's a V. And you're stating how much risk you're willing to accept, right? So when you set an alpha, you say, hey, look, I'm willing to take a 10% risk, or I'm willing to take a 5% risk. And so this would correlate to an alpha value of 0.1. This would correlate to an alpha value of 0.05. Right? And if you were a crazy person and you said you wanted a 70% risk, right, that would be an alpha value of 0.7, or a significance value of that, right? but the cool thing is that you can look at the alpha, and for example, as alpha goes up, your probability of committing a type 1 error goes up as well. Okay, so if I look at these things, right, this has the highest alpha value, and so this study would have the highest chance of committing a type 1 error, right? So this is why when we say, like, we're setting our level of risk, when we pick an alpha, right? I have a 10% chance of committing a type 1 error. I have a 5% chance of committing a type 1 error. I have a 70% chance of committing a type 1 error. Now the opposite can be true. We can say, hey, as alpha goes up, well, the probability of committing a type 2 error goes down. Okay? So bigger alphas, right? So this matches with this, and this one goes up here with this one. So this significance level has a really high chance of committing a type 1 error, really big chance, but it has a really low chance of committing a type 2 error. Okay, so like looking at your study, you need to decide, like, where do you want your risk to hide? Do you want it to hide in a type 2 error, or do you want it to hide in a type 1 error? Okay, and due to the fact that when you do a study, you're trying to reject, right? You want your type 1 error to be really low, because this is the thing we're trying to do. We're trying to reject H naught, and so we want to have a really low chance of that being the mistake that we made if we end up rejecting it and accepting, like, our conclusions or whatever it is that we're thinking about. So that's a little bit about how these two things work, looking at hypotheses and looking about the different types of error. If you have more questions about them, let me know. Thanks. Bye.